All right, guys. Now we've looked at two methods so far. We've looked at solving linear systems by graphing, and we've looked at solving linear systems by substitution. Today we're going to look at a method called elimination. Now, sometimes this can be tricky, but we try to simplify it as much as possible for you as we go through this. All right? So, first, when we think about the word eliminate, we want to think about what does that mean? Okay, well, I'm sure you realize eliminate basically means to get rid of something, right? So just like if you have a word that's typed, you can hit the delete button, you eliminate it, you get rid of it, it's gone. So the idea behind the elimination method is we're trying to get rid of one variable at a time to be able to solve for the other variable. And then we can substitute to find the ordered pair. So let's go through an example together, and we'll use the elimination method. Now, I've kind of written down some steps for you, and hopefully it'll make it easy for you to follow this. It's a generalization of the steps, so obviously each question and each problem that you do is going to be a little bit different. So let's start with this one that's here. The first thing that you're going to want to always do, regardless of the equations that you have, is to be able to match the equations with like terms, with one equation on top of the other. So for example here, you'll notice that I put the 4x over the 3x and the negative 2y over the plus 2y, and then the equals over the equals and the constants over the constants. So I'm matching up my variables. That's one of the key parts, is to match your variables up. Okay? Then from there, we want to make the coefficients. Remember, the coefficient is the number before the variable. So we want to make the coefficients be the opposite signs, but the same value. So in other words, if I have, like I have here, a minus 2y, I want the one down below it to be a plus 2y. So I want my coefficients to both be the same number, so they're both 2's, but see, they have the opposite sign. So one is negative, one is positive. This is what we want to be able to eliminate. The whole idea behind that is because we can then move to step 3, which is adding the equations straight down. So in this process of adding the equations straight down, you're going to notice that negative 2y plus 2y will give you 0y. If this is 0y, you have now basically gotten rid of the variable for y. So it allows us to solve for x. So 4x plus 3x is 7x. Again, minus 2y plus 2y is plus 0y, and 2 plus 12 is 14. So from here, we can now start to simplify things. Remember, 0y is basically 0 times y, and 0 times anything is 0. So we don't even need to write this part down. So we just go straight and we have 7x equals 14. And now you're all pretty aware of how to solve this, right? The inverse operation of multiplication would be division. So you divide both sides by 7 and you get x equals 2. Now we're not finished. So far we've only found the x value that works for both equations. Now we need to find what's the y value that would work for both equations. So we're going to take our x value and we're going to substitute it in to one of the original equations. It doesn't matter which original equation. I just chose the top one for now. So let's go ahead and replace the variable that we solved. So we solved for x. So we're going to replace that variable back into the original equation so we can find the value of y. When I substitute in for x, I have 4 times 2 minus 2y equals 2. And now we can go ahead and solve for y. So 4 times 2 is 8. Then we're going to go ahead and start isolating the variable. So we subtract 8 from both sides. 2 minus 8 is negative 6. So So negative 2y equals negative 6. Now we can divide both sides by negative 2. And when we do that, we get y is equal to 3. So x is equal to 2, y is equal to 3 in order to solve this system here, which means if I was to graph both of these lines on the same coordinate plane, their point of intersection would be at 2, 3. The last step, step 5, tells us to check that the ordered pair is a solution to both equations. So we go ahead and do that. We check it. So we can start by plugging it in to one equation at a time. We'll plug in the 2 for x and the 3 for y. As we simplify down, we find that 12 equals 12, and we're finished. What about the other equation? Because it has to work for both. So we start with the second original equation there, substitute in your x and your y, simplify it down, and it works. So now we know that the solution to this system is 2, 3. A second example. Now this one is going to require a little bit more work. And that's because if you already look at it, we were supposed to try and make sure that the coefficients are going to be the opposite signs but the same value or number. So if we're looking here, let's go ahead and follow our steps. And we'll address that when we need to. So first, we want to match the equations with like terms, one on top of the other. So as you can see here, I've already done that. I have the 3x over the 2x, the 2y over the 6y, the equals over equals, 9 over 6. So we can see all the terms are one on top of the other. Next, it says to make the coefficients, again, the number before the variable, be opposite but the same value. Well, that's a problem right now because we don't have that right away like the previous question. But there is a way to solve this issue. We can simply just multiply one of the equations by a number to guarantee that a coefficient is the same. So we have a 3 here, 3x and a 2x. We could try to multiply one of these, or maybe both of these, to get the same number. We have a 2y and a 6y. Well, the 2 and the 6, we can try and figure out a number that's easier here, because if you look, if this is 6 and that's 2, well, I can change the 2 into a 6 by multiplying it by 3. And then that would help us to get rid of the 6y, but then it would have to actually be negative. So if I multiplied this by negative 3, I'd end up with a negative 6y and a positive 6y. So that would help us to eliminate or get rid of this part. So what we can go ahead and do then is multiply our first equation by negative 3. Now again, all I'm doing is changing the way the equation looks. I'm not changing the actual value of everything. So I'm changing the way it looks in order for us to be able to solve or to eliminate one of the variables. So what I can do with the top one is multiply it by 3, negative 3. And the second equation, I'm just going to rewrite it and leave it the same. And you notice when I do that, 3 times negative 3 is negative 9. Negative 3 times positive 2 is negative 6. And negative 3 times 9 is negative 27. So now I have just multiplied the first equation by negative 3. By doing that and keeping the second equation the same, I have now helped us to find the same value here, 6's, but these signs are opposite. Because what happens when I have a negative 6y and a positive 6y? Well, the third step told us to go ahead and add the equation straight down. So when we do that, we're going to end up eliminating the variable y. As we continue to simplify, we can go ahead and solve for x, and x is equal to 3. Again, we're not finished. We need to find the value of y. So to do that, we replace the variable we solved for, which was x, back into the original equation, doesn't matter which one. And by doing that, we're going to go ahead and solve for y. So now we have the point 3, 0. But what's the fifth step? Again, the fifth step, the reason that we have you do this is to make sure that you're understanding how to do it correctly. Double check your work. Why not check the answer and see if it works in both? If it works in both, you definitely know and you're guaranteed to have the right solution there. So if we do that, we take both of the original equations. We're going to take our solution we found, which was 3, 0. We're going to go ahead and plug it in. Plug in the 3 for x, 0 for y. Simplify it down. And we get the right answer there. Now we try it on the second one. And it works there as well. So you can see that it's worked in both, so we know our solution is 3, 0. So with these two examples, hopefully they can help you in using the elimination method to solve a system of equations. Again, we've had 3 methods that we've learned to solve systems of equations. The first one was graphing. The second was substitution. And the third was elimination. So now you're going to go ahead and we're going to copy down some of the examples that we're going to go through in class. You can go ahead and give them a try if you'd like, but you don't have to. All right, see you next class.